Here we're given some different percentage sugar and densities for several different solutions. So a 0% sugar solution, or just pure water, has this density in grams per milliliter, and for example an 8% by mass sugar solution has this density. And what we're going to do is we're going to graph this data and make what's called a calibration curve. So here I'm going to show you how to do this graph using Microsoft Excel 2013 on a PC. If you have a Mac or some other version of Excel, it might not be exactly the same, but you are going to do a similar process, let's put it that way. So the first thing you want to do is select the data. I will want to have the X and the Y data, so that the X data is in the A column and the Y data is in the B column. And then I want to make what's called an XY scatter. So this is an XY scatter. I select that, and then I select the top one. Now, this chart isn't ideal, so what I want to do is click on this quick layout and then choose the one right here as a different layout. And the reason for that is that I want to have the chart title and the axes title available to me. It does put this series 1 on it. I don't really need that, so I'm going to go ahead and just highlight it and push the delete key, and I'm going to do the same thing with those numbers. So now I can label the axes and the title of this chart. So on my x-axis I have percent sugar, which is a mass percent over m percent, and I have a density, and that's in grams per milliliter. So I don't only want to put the title, but I also want to put the units. And then here, usually you put it as y values, in this case density versus percent sugar. So it's y values versus x values. So now I have a labeled graph. Now I want to make what's called a linear regression, and then make this calibration curve. So in order to make a linear regression, you want to select one of the data points. When I click on one of the data points, then all of them highlight. Then I want to click the right mouse button, click on Add Trend Line, and you'll notice this pops up over here. And I want to use a linear regression, and I want to use display equation on chart and display r-squared value. So now I have the equation of this line and the r-squared value. I'm just going to go ahead and make this a little bit bigger so it's a little easier to see. But now, whoops, I didn't mean to do that. I have the equation of the line and the r-squared value here. So the second question here is, what does the r-squared value mean? Well, the r-squared is a measure of how well the curve fits the data. So you'll see here that most of the points of data are actually on this curve. So the curve fits the data pretty well. So therefore, the r-squared value is close to 1. In this course, an r-squared value of 0.99 or better is considered acceptable for your data. If it's 0.98 or 0.97, chances are one or possibly more of these data points will be off the curve, and in which case you will need to fix that experimentally. But here we have 0.9945, so this is good to go. The next thing to notice is that this gives us the equation of a line. Y equals 0.0083x plus 0.993. This equation of the line is very useful because it can be very difficult to experimentally measure the percentage of sugar in something. So for example, if Coke wanted to know how much sugar was in Coke, I know it's high fructose corn syrup and not sugar, but if they did want to know how much sugar was in Coke, if they had that, then basically they could measure its density, which is relatively easy to measure experimentally, and then use the equation of this line to figure out how much sugar was in it. And believe it or not, you're actually going to do this as the third lab experiment in this course. So here it says, what is the percentage of sugar in a similar solution with a density of 1.068 grams per milliliter? Well, density is a y value, so I want to solve this equation for x. And believe it or not, you can actually use Excel to do this. If you would like Excel to do math, you have to type in equals. So we type in the equal sign. Now we want to take our y value, which is 1.068, this value here, and it is going to need to be in parentheses, because the first thing we want to do is subtract 0.993 minus 0.993. Now we want to divide both sides by the slope, 0.0083. So we divide this by 0.0083. And this number is the the percent of sugar, m over m percent of this unknown. So this is the mass percent of the unknown. Excel, just like calculators, will often give us the incorrect number of significant figures. So it's very important that we would round this to the appropriate number of significant figures, which in this case would probably be 3, based on these percentages of sugar and these known samples. So this is how we're going to use a calibration curve, and you'll use these quite regularly in the general chemistry lab.